Algebra lesson 4-5. If you are making a graph and you have a coordinate and you talk about the slope going up 4 and over 3, up 4 and over 3, would you say it's fair that the graph is constantly going up 4 over 3, up 4 over 3, up 4 over 3? The answer to that, absolutely. It's constantly going up 4 and over 3. Now, in a situation involving direct variation, we have something that we call a constant. We will refer to that constant of variation as the letter K. All right? The amount increased or decreased by when we're using the direct variation. I'm aware you're not quite sure what direct variation means just yet. Obviously, I'm going to go into more detail about that. But just remember that constant is K. Here is our definition for direct variation. Now, we will use one of these two expressions, y equals kx, there's that constant, or y over x equals k. And if you had this expression right here, and you wanted to turn it into the other one, it means you got to get k alone. In order to get k alone, you got to get rid of x, and the way we get rid of x is we divide by x. If you divide this side by x, you'd have to divide that side by x. The x's would cancel, and look what you have. Y over x is equal to k. So that's where this other expression, this other equation comes from. Now, if you have a positive k value, anything greater than 0 is positive. So if you have a positive k value, then as one of your values goes up, so will the other one. For example, a positive k value in terms of gas and money spent. The more gasoline I buy, so as gas goes up, so does the amount of money that I spend. There is a positive constant relating those two. And that positive constant is the amount the gas costs, $3.65 per gallon, or whatever it is. That's the positive k. Now, if k is negative, anything less than 0 is negative, then as one value goes up, the other value is going to go down. So, for example, the longer I run, the less energy that I have. That would have a negative constant, a negative connection. What's interesting is, and I mentioned about graphs going up constantly or down constantly, the slope of y equals kx is the k. And remember, we said the letter m represents slope. We're saying right here, k, constant, and slope, m, exactly the same. If you see a situation and you just saw this, y equals 3x, what represents the k? This represents k, but it also represents m. Constant and slope are exactly the same, because a slope will go up or down constantly by that same amount. Now, as far as our graphs, anytime you have a k value that is greater than 0, in other words, k is positive, your graph is going to go up because it has positive slope. As we mentioned before, reading them from left to right, positive slope. All right? This is one value. This is the amount of gas that I'm buying. As the amount of gas I'm buying goes up, because remember, going up is to the right, the graph is going up this way as well, which means the cost is going up. If you have k is less than 0, which means it's negative, then as I run more time, my energy level goes down. And as you look at that from left to right, it's got a negative slope. So it matches up with what we've said before. Now, this first scenario here, this first example, one of the key words that you'll see is they vary directly. The moment you see that, you start thinking, oh man, y equals kx. Yeah, how do I know it's y equals kx? Because it said they vary directly, and the definition for that means y equals kx. So I look for that key word, and I know I'm dealing with y equals kx. They've given me x and they've given me y, but they have not given me k. So from there, I want to write an equation that connects, that relates x and y. What usually happens is people will put those values in and then just stop. So they go, well, okay, I know that x is negative 3, and I know that y is negative 30, but I don't know the constant. And they stop right there. And then I have to mark it wrong because they haven't written an equation that relates them yet, because they don't even know what the constant is that is actually doing the relating. What's the connection? You should be able to solve. Divide by negative 3. Divide by negative 3. A negative divided by a negative makes a positive. And we have 10 is equal to k. And that's where the next group of people stop that I have to mark it wrong. We're not done. We've just found what k is. We still have to write the equation that connects, that relates x and y. So they go over to their next situation and they go, okay, well, negative 30 is equal to 10 times negative 3, maybe that's it. But this is just an equation that says negative 30 is equal to 10 times negative 3. It's not the generic form allowing me to use that equation. I want to be able to use this equation if somebody starts giving me new x values. So this is not good enough. If I see this, I have to mark it wrong. What we want is y equals the newfound constant with the generic y and x just waiting for values to be plugged in for x to equal to y. So this is the connection between x and y. The connection is take your x and multiply it by 10 and you'll get your y value. Okay, great. Now that I know that connection, see if you can use the connection to find this y value when x is equal to 8, which means y equals 10 times 8. So y equals 80. Because the relationship was y is whatever x is times 10. Now remember, this was a positive constant, which means as one value, x, goes up, so must the y value. Here, x was equal to negative 3, now it's equal to positive 8. That's definitely a rise. Since it's positive, the y better rise also. From negative 30 to positive 80, that's also a rise. So it works. Be careful. This is the form you must write it in. Y equals the newfound constant times x. Okay? And you should be able to look for this keyword, direct variation, to tell you the expression to use, then the given values put together to allow you to find that constant.